All right, welcome to the fourth unit of the spring semester of PreCal for seniors. This is the first day of notes, so we're going to go back to some of this trigonometry stuff that we took a little break from. So what we're going to discuss in this unit is called polar. Polar is dealing with a coordinate system that is based on circles. So uh, you can see down here, this is a polar graph. So instead of having a bunch of squares like an X and Y axis, you have a bunch of circles that have a different radius. So depending on a scale, you can safely assume this is one. So this is like radius 1, 2, 3, 4, 5. And you can see on the outside here that this is broken up by angles. So polar deals with points that are r and theta. So r representing the radius of the circle, theta being the angle. So let's just jump right in. And how do I plot points in the polar plane? Well, it's kind of weird because usually with x and y points, you start off with x and go to y. With polar points, it's easier to go to the angle and then do the radius. So we find 60 degrees. So this is 60 degrees here. And then you're going to go 1, 2, 3, 4, and then plot a point. And that is where point A lies in the polar plane. And that's it. Okay, and then you can go to 300 degrees, and then we have a radius of 3, so 1, 2, 3, and you plot a point there. And that's the polar point B. Now, the crazy thing about polar is that you can actually have negative radiuses and negative angles. So what happens if you go to 90 degrees, which is here, but go a -2 radius? So what do y'all think that does? Well, actually, like if you think negative, it goes in the opposite direction. So instead of going up on 90 degrees, we're going to go -2 and plot a point there. So this is where the polar point C lies. Well, what's interesting is that you can actually say that if you went to 270 degrees, that would have been the radius 2. So that would have been a different way for us to ask you to plot that point, which is going to go into our next set of notes. There are 4 different ways of writing a polar point. You can have positive and negative radii and positive and negative angles. So here we have the radius of 3 at -135 degrees. So if you notice, -135 or positive 135 is not in this like labeled, but it is our like reference angle 45 degrees, so it's like right in the middle of those. But if I was going positive 135 degrees, I would have been here, but -135 degrees ends up being over here in this quadrant. And then we're going to go to its radius 3, so 1, 2, 3, and plot a point. So this is the point that we're dealing with, and there are a lot of different ways to get there. So again, the first one that we did was we went in this direction, -135 degrees. What you could have also done was I could have gone in the positive direction and got to that same point, but that would have gone 225 degrees. So I'm going to rewrite this point as 3, 225 degrees. So that's another way of writing the exact same point. Now, what I need you to do is I need you to use your imagination because I'm about to show you something on this graph that isn't really there, and it's this point here. This point here is the reflection of the point that we are trying to plot. So this is an imaginary point. So this is where I want you to use your imagination. So this point's not really there, but we need to see it on our notes so that you know exactly what I'm doing. So what I'm going to do is I'm going to figure out, okay, well, how do I go from here to this imaginary point? Well, that is going to go 45 degrees. But if I tell you to 45 degrees, we're not going to get back to this point here. We're going to get to this point. So how do I go 45 degrees but end up over here? We have a negative radius. So that other point that we could do is -3 radius with a positive 45 degrees. Sorry. And then lastly, what could I do to go in the negative angle direction? Well, if I go all the way around this way and get to this imaginary point there, that went a negative 315 degrees. So that's going to be our other way. So we're going to go negative 315 degrees. However, negative 315 will end up here, but I don't want it to end up there. I want it to end up here, so we need to do the negative radius. So that's why it's going to be negative 3 and negative 315. So notice that two of my points have a positive radius, but one has a negative angle. They don't want positive. If the same thing here, if the negative radii, then those there. So there's a lot of different ways that you could kind of formulate this if you want to, but when you're talking about writing it in four different ways, I just feel like visually seeing what's going on is really helpful. So those are that's how you write a polar point in four different ways. Well, the other plane that we have been, dealing with since maybe elementary school is called rectangular, because it's a bunch of rectangles, or specifically squares. So there is going to be a way to convert from one to the other. So we're going to need to use these formulas here. So we have a formula where x equals r cosine theta and y equals r sine theta. Then we have a formula over here that says tangent of theta is the same as y over x, which makes sense because that was from the unit circle. And then we also have that r squared equals x plus y squared, because again, part of the unit circle. And then this triangle here kind of can show you how to get, the x value if you have the radius and the direction angle. So what's very helpful with some of these is actually visually seeing this. So if I'm asking you to graph something, it's most likely just like I'm going to give you the polar plane. But if I'm just going to ask you to sketch something, we can just look at this. So this is just a very rough sketch of the polar plane, where you would start here on at 0 degrees, 90, 180, 270, and back to 360. Well, if I'm asking you to plot the point 180 degrees, or 2, 180 degrees, we go to 180 degrees and we go to the second circle. So that's where our point is. Which visually, if I ask you, well, if you just looked at this graph and I asked you to label the point as x comma y, what would you write? Well, negative 2 comma 0. And that's it. That's all you have to do. If you don't like that visualization and you want to use the formulas, well, since I gave you a radius and a theta, and I'm asking you for an x and a y, well, that's going to be that x equals r cosine theta formula. So x equals 2 cosine of 180 degrees. And then the y is r times sine of 180 degrees. Well, how do I get negative 2 and 0? Well, this is where you have to remember your unit circle. So make sure you practice it and draw it out if you need to. Cosine at 180 degrees is negative 1. So if you multiply that by 2, you get negative 2. Sine at 180 degrees is 0. So if you multiply that by 0, or by 2, you get 0. So same answer. You still get negative 2 comma 0 as your x and your y, given that r and theta. So that's all you're going to need to do. So what about root 3 and 30 degrees? Well, again, what I'm going to do is I'm going to kind of sketch this point out. So 30 degrees and root 3 to me look somewhere here. So this is your r and here's your theta. And if you're looking for a rectangular point, you're doing x and y. So you could use the unit circle values, or let me show you a different way you can do this problem. What if we kind of draw a triangle here? Okay. That doesn't quite look perpendicular. So that's better. All right. So they told us that the radius of this circle at this point is root 3. Well, and this angle here is 30 degrees. Well, something that the unit circle is all based on is special right triangles. So if that's 30 degrees, this side length here is going to be the shortest side length. So I'm going to call that A. The other leg is A root 3, and that means that the hypotenuse is 2A. So something that I know some geometry teachers teach is kind of drawing a chart out for these special right triangles. So if we have 30, 60, and 90, those side lengths were A root 3, and 2A. But in this problem, they told us the hypotenuse is root 3. So that means 2A's is root 3. So I'm going to do that work over here. So 2A is supposed to be root 3. So if you divide both sides by 2, you get root 3 over 2. So that means A, which is the side length that's opposite of the 30, is root 3 over 2. And then at 60 degrees, it's root 3 over 2 times root 3, which root 3 times root 3 is 3, and then over 2. So those are the side lengths of this triangle with the hypotenuse of root 3. Well, something that happened here is that this side length is x, that's y. So that length that's a root 3 is x, so that's 3 halves, and then y is root 3 over 2. You could have also kind of visualized that as like, oh, well, you're going root 3, or 3 halves this way, and then root 3 over 2 that way, so x and y, and that's your point. Or what you could have done as well is you could have used those formulas. If you had x equals root 3 times cosine of 30 degrees for your x, y is root 3 times sine of 30 degrees. If you want to do it this way, you have to make sure you remember your unit circle. So cosine at 30 degrees is root 3 over 2. So if you multiply that, you get 3 halves. Sine at 30 degrees is 1 half. So if you multiply those, you get root 3 over 2. So you choose a way. In this class, it's always going to be on the unit circle. It's either going to be a 30, 60, 90 triangle or 45, 45, 90. Either way that you do this, you still get the exact same x and y value for this rectangular point, given that polar point. So you choose. Which way do you like to do that? But again, what's very helpful is just visualizing these. So here they're asking us to convert this to polar. Polar is the r theta coordinates. So that means this has to be rectangular. This has to be x and y. So if I roughly sketch a coordinate plane, if I ask you to plot the point 0, 2, it's this point here. Well, what would the radius of that circle be? 2. What angle is this at? 90. Done. That's it. What if I ask you to convert this? So again, this is going to be x, y, because we're asking to put this in polar, so this is r and theta. So if I roughly sketch out this point, I'm going to put this point over here. This is -1 and +1. So to kind of help out with what's going on, I'm going to draw a triangle. I'm going to take that tick mark off because it was just a little drawn poorly. But all right, so with this, we can kind of talk about a triangle. Well, if this is going to be a right triangle and I went one left and one up, that means that this are both the same side length. Well, that makes this a 45, 45, 90 triangle where the hypotenuse is a root 2. So like I did earlier, what I'm going to do is I'm going to kind of create a table. So we have 45, 45, 90. We have A, and A root 2. So it doesn't matter which A it is because we went one left and one up. So that means A is 1. So that means the hypotenuse is 1 root 2, or just root 2, which that is our radius. So part of my coordinate, polar coordinate, is the radius of that point. So root 2. Now the question is, what is the angle? So we figured out that it's an isosceles right triangle, so it's a 45, 45, 90. So the question is, what is 45 degrees in quadrant 2? Well, 135. If you want to do it any other way, you can. Again, there's 4 different ways of doing this polar point. So that is the polar coordinate of that rectangular point. And again, if you really want to see it, I can tell you that if you want to use the other formulas for r and theta, what you would have to do is the r squared formula. So r squared equals x squared, which is negative 1 squared plus 1 squared. So you get r squared equals to negative 1 squared is 1 squared is 1, so you add them up, get 2. So you get r equals positive or negative root 2, which, again, polar points can have positive radius or negative radius. It's up to the problem. However way you want to write it, there's 4 different correct answers. Then we had tan if theta equals y over x, which is 1 over negative 1. Well, if you're going to do an angle measure, we have to do tan inverse of negative 1 over 1. Doesn't matter which one's negative. And you find out that if I ask you for the rainbow value of this is negative 45 degrees. Well, negative 45 degrees is not 135, but if you added 180 to it, like what we usually do because this point's in quadrant 2, you get 135. Or again, there are 3 other ways of writing the exact same point. So you choose what method that you do. I like to enforce the special right triangles because it doesn't require you to memorize things from the unit circle. You have the special right triangles. So here's another problem. We have x and y, and I'm asked to write a polar point r and theta. So what I'm going to do is I'm going to roughly sketch this. I know this point is in quadrant 4 because it has a positive x and a negative y. So here's going to be my hypotenuse. There's my right triangle. And so this is 2 and this is negative 2, which it doesn't matter. Like we're just talking about the triangle. So we can kind of refer back to the last problem. These are both the exact same. So this is going to have to be a root 2. This is going to be a 45, 45, 90 triangle. So 45, 45, 90. We have a root 2. And we found out that our side lengths, our legs of the triangle are 2. So that means that the hypotenuse is 2 root 2. So there is part of my answer. There's my radius, 2 root 2. But then I know that this triangle is in quadrant 4, but the reference angle is 45 degrees. So there's, again, a couple ways you can do it. If you want to stick to just 0, 360, what is 45 degrees in quadrant 4? It's 315. So that's one answer that you can give me. You can also give me negative 45 degrees. That would be a quick answer that you can do. There are other ways of doing it. Just for the sake of notes, if you're the type of person that wants to use these formulas, we have r squared equals x squared plus y squared. So r squared equals to 2 squared is 4, negative 2 squared is also 4. If you add those up, you get 8. But if you square root 8, you end up getting 2 root 2. So I'll show that. So that's how I get that radius. And again, your radius could be positive or negative depending on what angle you use. If you're going to use these formulas, you're going to eventually need to do inverse tangent of the y value over the x value, which gives you negative 45 degrees. That's the rainbow value. And again, if you want to use negative 45, that's fine too. But since we're in quadrant 3, you would have to add 360, and that's how I get 315. So again, you choose. Both of these are give you the exact same answer. It just depends on what your process wants to be. So here's another x and y convert to polar. So what I'm going to do is I'm going to sketch this. I have a negative x and a negative y. So that means that this point is over here in quadrant 3. So I'm going to draw my triangle. So trying to make sure that that's perpendicular. Almost had it. Oh, that's close enough. All right, so the x is going to be negative 2, or just, yeah, and then the y is negative 2 root 3. Notice that those aren't the same. So how do I figure out which one's longer? Well, if you kind of think like, well, root 3 is something bigger than 1 but less than 2. So if you multiply that by 2, that's going to be the longer one. So this 2 root 3 is going to be the longer one. This one's going to be the short one. So that means this is a root 3, and this is going to be 2a. So this is going to be a 30, 60, 90 triangle, where if we're talking about this being a root 3, this is the longer leg, the opposite side length of, or the opposite angle of the longer side length is 60. So we have 30, 60, 90. Those are our two options, 45, 45, 90, or 30, 60, 90. There's no in between. So 30 is A, the leg opposite of 60 is A root 3, and then 90 is 2A. Well, we pretty much found out that A side length is 2, this is 2 root 3. So if you're talking about the radius is just twice A is 2, so 2 times 2 is 4. So there's your radius, it's 4. Then how do you figure out the angle measure? Well, it's a reference angle of 60 degrees in quadrant 3. Well, 60 degrees in quadrant 3 is 240. What's going to be more challenging about doing that second method, if you're wanting to see that, is that you're doing r squared equals x squared plus y squared, which gives you negative 2 squared is 4, and negative 2 root 3 squared is negative 2 squared, which is 4. Root 3 squared is just 3. So then you have 4 times 3, which is 12. So you get r squared equals 16. And if you square root both sides, you get the same radius of positive negative 4. If you're going to look for that angle, you're doing tan inverse of the y value, which is negative 2 root 3, over the x value, which is negative 2. So you end up getting tan inverse of root 3, which you have to remember is 60 degrees. But that's an answer in quadrant 1, where we're in quadrant 3, so you have to add 180 to that to get to 240. So in the video notes, I try to show both ways just in case you like one way versus the other. I find it very helpful to be using the special right triangles, the 30, 60, 90, and the 45, 45, 90 to figure out those radiuses and angle measures. But either way you do it, you get the same answer. So polar could be kind of fun. It just takes a while to kind of understand it. You just still need to use some of your geometry and problem solving skills that you have been using all year. So if you have any questions, let me know.